All right, guys. Quiet, please. Quiet, please. Okay, so we're gonna. This is a 2-day thing. I've broken it up into 2 lessons. So tomorrow's 7.9. We're gonna be solving more. They get a little bit harder tomorrow. Today we'll start off a little easier. But basically, we're solving equations that have rational expressions in them. So, let's see. So tomorrow's our last lesson for this unit. Wednesday we don't have school. And so on Thursday and Friday, you guys will be taking your tests for the class. I think what's going to I'm not sure, whichever one's shorter. One day we're going to do the Unit 7 Part 2 test. The other day we're going to do our review test, and I'll give you a study guide for the review questions that'll be on there. But whichever one of those tests is shorter, I'm going to put on Thursday. It's probably the review test. I'll probably end up putting the Unit 7 test on, but they're both pretty short, honestly. Anyway, so that's our plan. So we just have these 2 lessons, 2 tests, and that'll take us to the end of this week, and after that we're moving on to our next unit. So let's go ahead and begin here. So let's talk about something called excluded values. So we've actually already talked about this earlier this year. I think earlier this year I called them extraneous solutions. Yeah.
So like, is this like going to be like a lot of like steps?
There are a lot of steps, but that's not the meaning of this word. Does anybody remember what extraneous solutions were? We talked about them with square roots, I think.
Numbers that are solutions but can't be correct.
There you go. That's the definition. So sometimes when you're solving equations, even if you do all the steps right and you actually get all the right numbers out of it, it's possible that you could actually end up with an answer that's not allowed. And what you do basically is you just plug it in and see if it works. If it doesn't work, then you throw it away. That's one way to do it. Now, that's how you check to see if it works. But here we go. We're going to find excluded values. So for rational expressions, anything that makes the denominator equal 0 would be your excluded values. So in other words, x cannot be any value that if you plug it into that rational expression, it can't make the bottom equal 0 because fractions aren't allowed to have zeros in the bottom. So we're actually not going to start by solving equations. We're going to start by looking for excluded values, and then we're going to use that when we actually get to solving equations today, where we're going to get answers. We want to make sure that those are not excluded values, because if they are, we throw those answers away, because excluded values are not permissible as solutions. So that's what an excluded value is. I guess I didn't finish my sentence there. They're excluded values, and that means they can't be a solution on an equation, basically. All right, so let's hit up an example here. Identify any excluded values. Identify any excluded values. All right, so we'll start off with something simple here. I'll do 2 examples, one easy, one a little bit harder. So the question here is, what value is A not allowed to equal? Okay? What is A not allowed to equal? That's what they mean by identify the excluded values. What is A not allowed to equal? Well, no, A can equal 0, but the bottom can't equal 0. So here's how you start. You take the bottom and you set it equal to 0. The bottom can't equal 0, right? So now I'm going to solve for A. Yeah, because that means it can't equal it. That's what we mean by excluded. So A cannot equal negative 6/4. Or you could say negative 3/2. This wasn't factoring actually, but I will do one like that in a second. But there it is. So anything that makes the bottom equal 0 is an excluded value. So the bottom can't equal 0. Solve from there, and that tells you what A is not allowed to be. A is not allowed to be negative 3/2. Huh? Oh, sorry. Is that good?
Yeah.
Now, this next part I'm going to write, you don't have to, but I want to demonstrate something to you, okay? Just watch. I'm going to go ahead and plug in A. I'm not going to really worry about the top. The top doesn't matter, but let's plug in, and once again, you don't have to write this. I want you guys just to watch, okay? What would happen if I did plug in negative 3/2 for A? Well, 2 would go into 4 twice, right? And 2 times negative 3 would be? And negative 6 plus 6 would be 0. And now I have a 0 in the bottom of my fraction. That's not allowed. Now, some of you guys said A can't be 0. Well, A can be 0. Let me show you why A can be 0. Because if you plug in 0 for A, you would have 4 times 0 plus 6. That just makes that go away. And what am I left with in the bottom? That's allowed. You can have a 6 down there. You can't have A is equal to negative 3/2, because if A equals negative 3/2, then the whole denominator becomes 0, which is undefined. You can't have that. So that's what they mean by an excluded value. Any value of A that would make the bottom turn out to be 0. And in this case, it's negative 3/2. All right, so this one was a simpler example, and the reason I say that is because it's just a simple linear equation. You just subtract and divide and you're done, right? So I'm going to give you one that involves some factoring. So let's go ahead and write down number 2. B squared plus B minus 12 over B squared minus 2B minus 24. Okay, so I'm going to take my denominator, right? I'm going to set it not equal to 0, I guess you could say, right? An equal sign with a slash through it, like that. The bottom can't equal 0, that's what that means. And then I'm going to solve this. Now, the way we're going to solve this one is by factoring. Sometimes you could do a GCF, sometimes a difference of squares, sometimes a box method. What would that be? That's a box method. Now, I'm not going to show the work for the box. I'm just going to say do the box method. If I were to use the box method on this, let's see, I would get minus 6 and 4, I think. The 6 is the negative one, 4 is the positive. That's interesting. And then what we do is we set each piece equal to 0, right? Sorry, I'll bring that back up a little bit. All right, so we're going to do B minus 6 can't equal 0, and neither can B plus 4. So that means that B cannot equal 6, and B cannot equal negative 4, because if it does, what would happen? You get 0 in the bottom, and fractions can't have zeros in the bottom, right? So those are the excluded values. Excluded means not allowed to be included, right? It means it can't equal that value. So b is not allowed to equal -4. Now, if you guys don't put the slash, you put equals, I think that's technically fine as well because you're answering the question, what values of b are excluded? Well, b equals 4 is excluded. You could say that. I'm just thinking of it as b can't equal -4. It means the same thing. So if you don't want it, if the little slash through the equal sign confuses you, then don't put it. It's fine. All right. So we're not technically solving equations right now. All we're doing is we're finding the values that are excluded. So I'll give you ones just like I had. I'll give you an easy one and a harder one. There's our easy one, and then I'll give you a harder one. Okay. So I want you guys to understand what we just did here. Our goal here is really to be solving equations, okay? But I did that as like a first step so that we know that when we're done solving an equation and we get an answer, we understand what I mean when I say, oh, we can't use that answer because it's an excluded value. Okay, so now we're going to actually begin the main objective for today, which is solving for x and an equation that has rational expressions. So we're going to start off with some easier ones today. And then by the end of tomorrow, you'll see as bad as they get. The only thing that really makes them bad is how well you know how to factor and multiply with polynomials. That's pretty much it. So let's go ahead and write this down. This is example 2. And the question here is asking us to solve for n. Solve for n. So now, guys, I would kind of like you to be able to look at it and know the excluded values. Now, in the last two problems, that's a little hard to do. But on this one, I think it's pretty easy. Just look at this. What would I not be allowed to plug in for n? Because if I did, it would make the whole bottom become 0. -5? No, because that would be -25 because they're multiplying. 0. So the only thing that n is not allowed to be is 0. So long as my answer doesn't come out to be 0, I'm good. Okay? All right. So let's go ahead and begin the problem. So I'm going to solve this the same way I've solved all my problems in this class with fractions. I want to get rid of the fractions first. So I'm going to make a little space here. I don't want all this stuff in the way. I like the binomials to be in parentheses because it reminds me to distribute, which oftentimes we need to do with those. All right, so here we go. I want to get rid of the denominators. So if I wanted to get rid of this 5, what would I have to multiply this fraction by? Well, you're answering a different question.
You have to get rid of it, not make them look the same.
That's it. So you guys are asking how can I get a common denominator? I don't want that. I want to know what would I multiply this fraction by to cancel the 5? And the answer is 5. All right, so check this out. So here's what I'm going to do is I'm going to multiply everything by 5. Ready? Times 5, which is cool. You're allowed to do that because I don't want that 5 there. I don't like fractions, so I just unfractioned that thing. But you're only allowed to do that if you multiply everything by 5. You're only allowed to do that if you multiply everything by 5. Just the tops. Thank you. Thank you. So let's make a little note there. Multiply.
When you unfraction, you just multiply the top.
Yep. Multiply the numerator, each numerator, I should say numerator, by the denominators. Okay? So let's see what we have left. And by the way, does anything else cancel? Right there, right? That's nice. So now here's what I've got. I've got n minus 1 over n. Notice that one got a little bit simpler because it lost the 5 on the bottom. The one over here did not get any simpler. It's going to be 15 over n now. And this one is what's left on the right there? Just 1. So I unfractioned it. And we're just going to keep unfractioning these things. What would I multiply the next one by to get rid of the n? N. I'm allowed to multiply this by n so that these cancel if I multiply everything else by n.
So then it's n squared minus 1n.
Let's see. So now we have these go away also, right? So now I've got this. N minus 1 equals 15 minus n.
Wouldn't that be 15n?
No, because these canceled. That's why we multiplied it by n, was so that we cancel the bottom. So there you guys have it. No more fractions. So this is the main trick here. Multiply each numerator by the denominators as many times as you need to until all the denominators are gone. And then, well, the problem's not solved, but we've unfractioned it. And so now it's a lot prettier to look at. And now we just get to do some algebra, some of the simpler algebra from the beginning of the year. So, how would I get these n's together? What would I have to do?
You have to multiply.
I'm going to add this in over here, so that's gone, right? But whatever you do to one side, you do to the other. And so what that's going to give me is 2n now, right? N plus n, you can think of that as 1n plus 1n, is 2n. So if you have n's on both sides, just add or subtract 1 to the other side, right? And now we need to solve this. So from here, I would think you guys know what to do. You would
Got it. I got the answer.
add 1 and divide by 2. What was our excluded value?
8.
It was 0. Is that what that is? No. So this is a good answer. That's the answer to the equation. If we got 0 as an answer, we would have to say that's not really an answer. That's an extraneous solution. That's an excluded value. Okay? So that was your teacher example. We're going to do a guided practice from you guys walk me through each step, and then I'll let you guys do one on your own, and then we'll call it a day, okay? All right. Okay, so let's do this one instead. All right. So I'm going to just call in somebody, ask them a question. Ready? Rowan, what would we do here?
Multiply by m squared.
Sure. So Rowan's told us to multiply by m squared. Let's do that. But,
It's only the top,
oh, that's right. So she chose m squared because that's one of our denominators, right? Ooh, that's interesting. So that's why she chose that. You could have also chosen to multiply by m. You could have also chosen to multiply by 5. But we'll leave it at that. Now, Mr. Bailey likes to do something with his binomials. What does Mr. Bailey like to do with his binomials, Danielle? Put them in parentheses is right.
Yeah, I didn't hear him say anything.
So that would be my suggestion, because if you don't do that, you're going to forget that it's actually a distribution thing if there's actually a number left out there. So you guys go ahead and do the first step there. Go ahead and multiply everything by m squared. I'll pause. Huh? You didn't get it? Okay.
I did.
Okay. Want to tell us what you got there, Hannah? Go ahead.
I got 1m to 1.
Okay.
Over m.
Okay.
And equals
Uh-huh.
m plus 4
Okay.
plus m minus 5 over 5.
Over what? Now we can actually do a little bit more right here. It's not immediately obvious, but you guys see what we can do there?
That'd be m cubed on the bottom, right?
No, we can reduce this. Yeah, what's m squared over m is just m. So if you guys want to do that, that'll make life a little bit easier. I would suggest reducing wherever you can. That way you have less to multiply. And the less you have to multiply, the better, because every time you multiply, there's a potential of numbers getting bigger and bigger and harder to solve. So reduce whenever you can. Okay, now I'm going to ask Heidi. What would I do next, Heidi? You sure? You want to take a guess? If you're totally clueless, that's okay. But if you have an idea, I want you to be brave. But if you don't have any ideas, you can say pass. No ideas? Okay. Go ahead. No distribution yet. No distribution. Let me go to Natalie. We're going to multiply everything by the last denominator, right? So we're going to multiply everything by 5. So you guys go ahead and do that. Want to tell me what you got after that step? Okay. Go ahead.
So would it be 5m?
Oops. 5m.
Equals parentheses 5m plus 20.
Okay. I'm going to put it out here, but you're right. And how about over here?
And then it'd just be m minus 5.
Good. Okay, so he's right, you guys. So let's take a look at this. So let's check it out. Yeah. So we said we would multiply it by 5, right? Which we're totally allowed to do so long as we multiply everything by 5. So that's why we have a 5m there. And this looks exactly the same there, right? But over here, those cancel. So I'm just left with m minus 5.
So that one's going to turn into 5 m.
Good.
Right? Okay.
Yeah.
Because I didn't do that, so I was like,
Okay. If there's no distribution, after you do the distribution, you don't need the parentheses anymore, because that's the only reason I like to have those there, is to remind students to do that distribution. So now we're ready to solve it. So I want you guys to go ahead and solve it from there. See how you do there with that solving. Go for it. Bonus point. I circled my answer because I'm pretty sure that's the answer, but technically, what should I do? Yes, Chris? No, not, but you're warm. Yeah? Maybe, right? And why would we do that? That's good. That's not quite the reason. I'll give you both points for that, but here's what it is. You need to make sure that your solution is not an excluded value. So that's negative 15, right? Let's go up to the original. Would 15, if you guys were to plug in negative 15, would that make any of these bottoms become 0? Then it's a good answer. Yeah, that's it. It wouldn't make it 0, right? All right, so that was your guided practice. I'm going to throw a student practice at you, and as soon as you're done with this, we can call it a day. Here we go. 1 over 3x squared minus x plus 2. Now, I'm putting parentheses on there for you. I probably shouldn't have done that. I should have made you do it. But there you go.
what is this?
This is your student practice. This is for you guys to do from beginning to end on your own. See if you can find the solution. All right, guys, so the answer is negative 8/3. So if you need help, just let me know.